RxJava. So I first would like to give you some context for this talk. First, introduce myself. I'm Hugo. I'm an independent software developer, Android developer at my company, Little Robots. And I'm also a GDE, Google Developer Expert for Android. And some of you might know me from, for example, the Android APT plugin that I wrote. But today I'm talking about RxJava. And the context for this talk is that I know that a lot of people might already use RxJava or have seen RxJava, but it's quite hard to figure out when you need RxJava, I think. And usually when you are solving a problem with RxJava, something like this happens. You have a problem, you apply RxJava to it, now you have more problems, and then you fix those problems and everything is happy again. So what I would like to do today is give you a taste of what RxJava can look like, how you can get started with it, and also show you some real life examples from apps that I built. And then I will also give you some tips and tricks to get started with RxJava. And if you want to learn more about RxJava, because there's impossible to tell you everything about RxJava in this one talk, we also have Eric after me presenting on more RxJava stuff. So let's go. Which problems are we trying to solve? Let's start there. So your typical code is, if you're in the happy path, you have something synchronous. You want to get an article, you just call the getter and you're done. Usually though, it's not that simple. You have something, this article needs to come from the network, for example, needs to come from a database, something that you can't really synchronously call to because you don't want to block the main thread. In that case, you can resort to something like a callback interface. But the callback interface has a couple of problems. It's hard to control lifecycle. You can't generally not cancel it. It's hard to chain multiple callbacks. So if you have to do multiple things, you have to coordinate all these callbacks. And there's no real standard way to do error handling. So probably your callback will have a success or an error handling. And then there is also the question on what thread is this callback returning. For Android code, you really want to return the result on the main thread usually, because you want to show it in the UI or that kind of thing. So async task is sort of a solution to that. It allows you to run a background task on a background thread. It allows you to cancel it as well, and also make sure that the result comes back on the main thread. So that's already an improvement, but it's still not great because there's still the problem of chaining and there's still the problem of error handling. Error handling with async tasks is kind of ugly. So when we would apply RxJava to this problem, we would do something like this. We would create an observable that returns us an article. And this is, of course, very abstract still. But a couple of interesting things to note here is that once you invoke this method, nothing is actually executed. It's just setting up an observable, a stream, that once you subscribe to it, will start giving you these article objects. So that's convenient. You can also pass this around to other methods. Also interesting here is that this call can be, once you execute it, once you subscribe to it, can be synchronous or can be asynchronous. It's not, you can't really tell from the declaration here. And an observable also has built-in error handling. So a couple of things are taken care here. We can cancel it. It can be either synchronous, asynchronous, or we can handle errors. And how does that work? This observable basically is emitting events, and there are 3 types of events. There's the value event, which comes back in the onNext method, and that means that every time an article is produced by this observable, you will get a callback. And there's a second type of event, which is the error event, which would result in termination of the observable at that time. So if you get an error from this observable, you are ensured that no other events are coming. There's a similar event called the completion event, which is basically completing the stream without an error. So you get this article, you get maybe one or multiple, and at some point the stream will complete and will tell you that it's complete. So if that's like the basic observable 101. I mentioned subscribing to this stream. Subscribing is the way to get the data out of these observables. And you'll notice that it's very simple. You just have to call this method, then you subscribe to it, and you give it a subscriber. And subscriber has these three methods that I mentioned. So it has an onNext. Every time an article is produced, we get an onNext event. If something happens, anything, you get an onError with a throwable. So it might be any exception, including exceptions that happened when you're handling stuff within your observable. And, well, if it's completed, it will tell you as well. And there are a couple of ways to create a subscriber. This is one way with just subclassing subscriber. A common way is to use inner classes for this. Basically gives you three inner classes for the same method, so the onNext, the onError, and the complete. This is convenient because when you apply this together with Java 8 lambdas, which are finally coming to Android in an official way, then you can shorten this to this syntax. And this syntax might not be that familiar to everybody, but it's basically how Android Studio would show you if you write inner classes. And it's also way shorter to show in slides, so I'm going to use this for the next slides. So this was my, oh, not yet. So of course you need to unsubscribe at some point. So it's pretty important that you keep track of your subscription. So this is what I'm doing here. We have the subscription and we get a reference to the subscription. And this is very important because at some point you need to unsubscribe. If you're done with this stream, you want to unsubscribe. For example, if you were have a fragment or an activity, you're dealing with lifecycle, you want to cancel this subscription. So you want to cancel the observable emitting events. So unsubscribe is always important. If you don't unsubscribe, then I think Enrique already mentioned it a little bit. You might leak memory because, especially when you use these inner classes, you will hold a reference to your fragment or to your activity or to whatever where you declare this callback. So don't lose these subscriptions. That's basically my point. If you subscribe somewhere, you always want to be able to unsubscribe. And there's no hard or fast rule if it will leak memory, but just assume that it will and then be on the safe side. Yes? Yeah. Any tips and tricks to yeah, I will get to that. Yeah. Show you later. Okay, so this was like the basic intro to RxJava. Who thinks this is complicated already? No, it's not too complicated, right? So still, RxJava has like a reputation for being complicated and have a steep learning curve. And basically, I think this is not really because this syntax is so complicated, but because applying RxJava to your application is really an architectural change. So it requires a different way of thinking about your application. If you are applying a library to do HTTP calls, for example, what you're basically doing is trying to reduce the amount of code that you're writing. So maybe you could write the same thing yourself in 20 lines of code, but then you apply some fancy library, and now it only takes 1 line of code. But if you apply RxJava, you're doing basically something in a different way. So you are re-architecting your apps for that. You have to be thinking of stream of events instead of doing a single callback or single get. And you also have to think about when dealing with these observables, is this an observable that will emit one event or multiple events? Does the stream ever complete? So is this like a single thing, or does it go on forever? Am I handling these errors correctly? I mean, it's really convenient that you have this one error callback, but it takes throwable, so it could be any error. Could be also errors that you wouldn't necessarily expect due to programming errors. And then there's the functional style of RxJava, which again, might not be familiar to all developers, especially if you have juniors on your team. It might be hard to get used to the functional style where types are immutable and where we are changing all the operations on the stream, because the observable itself is simple, but where the power comes from is manipulating the stream by using operators. We get to that. And there are lots of them. There are, I don't know how many, but there are, in the typical use, typically I use about 10 or something like that, but there are way more than that. And you can combine them in all kinds of ways. So that also means that you have to learn some tricks in a sense to figure out which combination of operators works. And there are many operator combinations for that. And another thing that makes RxJava maybe a little bit hard to learn is the documentation. There's actually pretty good documentation, but it might be very daunting to understand it if you see it for the first time. So this is an example of the Java doc. Let me see. Well, I hope you can see it. There's a lot of generics. It's already a little weird. And then there's this marble diagram, which is supposed to help you understand how an operator works. And this particularly is for flat map. Where is flat map? Something here. Yeah. So what this tries to express is that these are the events coming from the source observable. So the circles are the events. And then here's the operator. And this is the output of this operator. So what FlatMap does, it takes an event, and for every event that is emitted, it will produce a new observable that might produce one or more events. So you can see that the red circle, for example, here, is transformed to two diamonds here. And you can see that for the green and for the blue, the same applies. But you can also see that the order of these things are not necessarily in order. So we have first the green, then the blue, and here they are interleaved. So all this stuff is in the Java doc, but and it's in the marble diagram. But there's a lot of stuff to take in if you see this for the first time. And this is just a single operator. So I think if you are starting out with RxJava, this is probably that's probably a hurdle that you have to take to understand all of this. So I would really recommend to have a gentle start. Don't try to go all out reactive. This is amazing. Let's make everything reactive. You most likely fail if you try that, because like I said, it's hard to take gentle steps. But I would recommend to apply this where it makes sense, right? So I think where it makes sense is mostly in your domain layer or in your business logic. Maybe you have some data transformation that you want to do. It's very powerful for that. It's also very powerful for doing something like an HTTP call, like REST. And I would figure that most of you know RxJava from working with Retrofit, because Retrofit was very early on supporting RxJava. And it makes it really easy to get this observable, and once you subscribe to it, under the covers the HTTP call is being made and you get a result. So it's a really nice way to work with HTTP calls and getting rid of callbacks, basically. Another nice place to apply RxJava is where you are coping with this lifecycle. So if you have some operation that should stop when your activity or your application goes in the background, for example, well, canceling this now is just a matter of unsubscribing. So it's pretty easy to control this lifecycle and make sure that you're not crashing your app, for example, when your task, like things that might happen with a callback. You get this callback, your fragment is gone, you try to do something in this fragment and everything crashes. So, and another example is you can apply RxJava as a more specialized event bus, because in the end, what RxJava is doing is quite similar to an event bus. If you have like, it's sending events, but now it adds on some power where you can transform the events and subscribe to specific events that you are interested in. So it could be a nice change for removing an event bus. UI, it could be useful it is useful in some cases, but for the most part, I think the examples that I mentioned are more appropriate. Okay, so now I'm gonna switch gears a little bit and show you some of the RxJava that I applied in apps. And the example that I have here, this now hopefully that article is going to make sense. This is from an app where we scan inventory in shops with an RFID scanner. So we are actually scanning clothing. So an article might be a t-shirt or something else. It has a tag, and we want to, of course, in this app know which articles are actually in the store as in the way that we expect. So a very simple example or a gentle step of using RxJava here is that we need to convert an observable of articles back into an observable of their RFID tags. We want to know what a stream of tags, basically. And well, we can apply a simple operator for that. Given that we have this this observable of articles, for now it doesn't really matter where it comes from, but it might be a web server, it might come from a network call, for example. We are now going to map. The operator is called map. We're going to map the article to its RFID tag, so to its string. You can see it's taking the article and it's converting it to a string using this map. So that's pretty simple. But what's important to realize here that we are actually creating a new observable. We are creating a new observable that's wrapping the old one. So it's basically doing this. We're going to, it's a little bit like a string. If you're doing string.substring, you're creating a new string. Same for observables. That's something to realize. Because we are going to chain all these operations in the end. Does that make sense so far? Just mapping from one stream to another. So what happens if you subscribe to this thing? You will get a callback for every article, but you will get its RFID tag and not the article itself. Okay, so now I'm going to show you something a little bit more complex. If you're new to RxJava, it might be a little bit too complex, but the point of this is probably is more to show you what can be done and show you, how I wouldn't necessarily say easy, but how powerful this stuff is. So in our app, we have this requirement that we want to count and group the articles, the same articles. So we have a bunch of articles which might have a unique RFID tag, but might be the same article. So I might have 10 red t-shirts, for example, which all have a different RFID tag. And we want to group these articles by their article ID and then count how many I have in each group. And then I want to create a new object out of that, emitting an article quantity. So that is like the article ID with its quantity. So how many did I count of this? And this is actually how we're doing that. And I will go step by step. We have a couple of steps here. First, I want to filter out all the articles that are not supposed to be in stock. We keep track of the articles that we expect, but we are only interested in the ones that we are expecting, basically. So this filter operator will create a new observable, we'll chain it, and we'll filter out all the articles that are not in stock. Then we're going to group all the articles by using their RFID tag. And this notation means that we are calling a method which takes an article and then returns the tag. So it's the article IDs. Excuse me. So this is already quite powerful. So this is the marble diagram for group by. So take some time to let this sink in. When I saw this the first time, my head exploded. So what happens here? These are the various events, and then you have your function, your group by function, and what it then emits is not just new values, but it's actually emitting a new observable of observables. So what happens? All of these these circles are getting grouped in a new observable, and all of the triangles are also grouped. So we'll see on this slide, after we apply this operation, we now have an observable that has a group observable, string, and article. So the string is the key, is my article idea, and the article, of course, the article that I want to figure out, want to count eventually. So I hope this is not too complicated still. What we're going to do now that we have these nice groups, we can apply an operator on this group observable, which is flat map, which is the one that I've shown. So we get for every value event, which is now an observable, we want to do something with that. So we want to actually process every group. And so we take in the group, and then we're going to map the group, which is the same operator that we saw before. We're going to map this into a new object. So we have this article grouped by its idea, and we can create our almost final object, which is the quantity. So we get the article ID here, and we have a quantity of 1. So they're still not unique. So what happens now that for every article in these groups, we have created an article quantity object. So we're saying, well, here's 1, here's 1, here's 1. Now we want to sum up every article in this group, and there's another operator for that. It's called reduce. And what reduce does is it takes 2 objects and expects you to create 1 object out of it. So for every article quantity that I get in here, I'll just take the article ID from the first one, because I know they are the same group, and then I just sum up the quantities. So after all this work, we now have an observable that will emit an article quantity, unique per group, and will give me how many of each I have in the group. And I wouldn't necessarily tell you that this is easy. It takes some time for me to figure this out, but I do think it's very powerful. It's very powerful because all I need to do now is take this thing, subscribe to it, and I get this stream of events telling me how many white, red, green t-shirts I have. So that's very useful for us in the application, because it's basically just processing this data. I hope I didn't lose you now. Okay, because yeah, I have something more. Okay, so if you thought that stuff was not that hard, maybe, or great, good for you. We have another situation where we needed to do something more advanced. We have the situation where we want to create an object called the expected stock. So it's all the stuff that we expect, but also we want to combine all the RFID tags that we have seen. And there's a simple thing to do there. We can combine these previous functions that we made. So we have the RFID tags. We can convert it to a list, and we can do the same for the quantity. That was the complicated one from just now. Convert it to a list, and then have a function that creates a new expected stock object, which returns both in one object. But there's a trick here. This is this trick. We're going to take the original observable, then we're going to create that into a connectable observable, which is this one, and then we're going to tell that observable that we only want to start emitting values once we have 2 subscribers. So let me show this here. So a connectable observable The idea of that is that you create an observable, which is just a normal observable, but usually when you subscribe to an observable, it immediately starts doing its work. If you don't want to do that, you can use publish for that. You can subscribe to it with multiple subscribers, and then when you have set up all your subscribers, you can say, well, let's connect to it, and only then it will start producing values. So what this basically does is broadcasting this one observable to multiple subscribers at the same time. And AutoConnect makes this automatically in this case. I know that I have 2 subscribers, and once the second subscriber has subscribed, then the producing of these values starts. So this is why this works. I know we have 2 subscribers because we have the RFID tags and we have the quantity. We convert them to a list, and the net effect of this is that if this observable will trigger a network call, only 1 network call is made, and not 2, which is of course what we want. We want to be efficient on the mobile device. So yeah, and like I mentioned, we have combine latest, which basically combines the latest values. In this case, we know we only have 1 because we have 2 lists. Will be basically getting the whole observable, converting it to a list, will emit 1 value. So that was something more advanced that you can do. Again, data processing, I think that's a really good case for RxJava. So far, I didn't really talk about the synchronicity or asynchronicity handling of these things, but RxJava has a very powerful concept of schedulers, which allow you to control on which thread stuff is happening, which is of course very important for Android because you can't really block. Without applying any schedulers here, assuming that this thing does a network call, the whole processing might happen on the main thread, and you can't really do network calls on the main thread. So you can apply schedulers, and there are a couple of built-in ones. There is the IO scheduler, computation, but you can also create your own one from an executor. And there's for Android, there's a project called RxAndroid, which supplies a scheduler that returns your value on the main thread, or actually which does the work on the main thread. And there are 2 operators again. Everything is an operator that controls how you apply these schedulers. There are subscribe on and observe on. And again, I've seen some confusing statements about subscribe on, but the key thing to remember is that subscribe on you can apply basically only once. So if you have a chain of operators on your observable, you can only use subscribe on once, because the net effect is that subscribe on controls on which thread the subscription is happening. So the minute I call subscribe, it will create a new thread and then do all the stuff that is needed to subscribe. If you apply that multiple times, it doesn't have really an effect, because it will just create a couple of threads and end up where in the first subscribe on, basically. Observe on the other hand, controls where the event is emitted, on which thread it is emitted. So you typically use that with the main thread to make sure that once you get your result, you get it back on the main thread, and then you can safely update your views and that kind of stuff. So in this example, the map would be running on the IO thread, and then once the result from the map comes back, it will switch to the main thread, and then it goes on with another operator, flat mapping, or yeah, whatever. Usually, in the more common sense, you will have this as the last operator and then apply subscribe. There's also a nice caveat here that there are some operators that apply their own scheduler, and that can be surprising. Sometimes you apply you have all this, you've done all these things right. You have observe on, nice, and then you apply a scheduler, and all of a sudden it's still telling you that your views are touched on the wrong thread. Well, that might be because operators like timer and debounce might use a different scheduler if you don't tell them to use the scheduler that you like. So it's kind of tricky. Okay, so yeah, that's basically the basic ingredients you need to get started with RxJava, I think, if you have the schedulers and the and the observables and the operators. Again, I think small steps here. If you're already learning this, great, but don't overdo it, I guess. And that leads me into the common mistakes that I'm seeing in code. I've been doing some code reviews lately for various companies, and these are a couple of things that I see often. Yeah, subscriptions. This is probably the basic thing that I see a lot. If you're not keeping the reference to the subscription, you might leak memory. So there is a trick to make this a little bit easier to make sure that you unsubscribe. There's this object called composite subscription, and it's basically a bag of subscriptions where you can put all your subscription in. And once if you do it, for example, like this, if you are subscribing in onStart, you most likely want to unsubscribe in onStop. So you can add your subscription here, and when you're done, you call clear. And if you call clear, then it will unsubscribe all the subscriptions and basically cancel all the operations, or at least not return the results anymore. There's also an unsubscribe method on this thing, which you definitely do not want to use, because if you call unsubscribe, then the next time this activity comes back, it will try to add the subscription, but it will immediately unsubscribe it again. So that's probably, if you're using this thing for the first time, you might run into. So use clear. That's the basic message here. And another thing that is very common is error handling, or better, forgetting to handle these errors. You should always make sure that you subscribe and supply an error handler, because if you don't, especially in the case where you're applying a scheduler, you'll get this stack trace that shows you basically nothing. That shows you, well, something went wrong here and here deep down in some RxJava class, and you have no clue where it happened. So if you should always be using these error callbacks, and if you are, then you should always log the error coming in, because it might be something unexpected. It happened to me a lot of times that I was handling the errors that I expect. So if it's, for example, if it's an IO exception, then I do this and that, and if it's something else, I do something else, and then all of a sudden I get a null pointer exception, I didn't log it, and nothing happens, and I have no clue where it came from. So make sure that you log these exceptions. And I've written a lint check called arglint, which can also help you flag that code. So if you don't use an on error callback, it will tell you, hey, you might want to add this here. This is kind of a funny one that I see a lot in code for some reason. I don't know. There's the people that are longing for an async task, and they probably think, well, we have this RxJava thing, let's make a very complicated way of doing an async task. So what they would do is they create this observable, they subscribe to it, apply these operators, nice, and then something weird happens. In the subscribe, they certainly all of a sudden go out to an event bus and post the event. I mean, if you're doing this, then just use async task, right? It doesn't make sense. What you should probably be doing here is create this observable, then subscribe to it and handle it in that way, because that's how you are applying RxJava. If you do it like this, there's no real benefit of using RxJava. You just have a fancy way to schedule some kind of work. But again, I've seen it a couple of times already. Especially in combination with retrofit, where people are like, well, we need to fetch this thing from the network, let's do it like this, and then post the results on an event bus. Another thing that's common, which I see once in a while, is people are breaking the stream, so to say. So we have, for example, we have this map operator, and then we realize that we want to do something with that value coming into the map. So why not create another observable here and subscribe to it and stuff? But that has all kinds of problems, because you, again, might not keep a reference to the subscription, but also because you're not now breaking out of the stream. You should probably, in this case, use flatmap, because that allows you to return a new observable based on a value that you get in. So this create observable, the thing that you create here, you would then return in flatmap. There might be some common cases where you actually want to do some side effects. That's fine. There are operators again for that. There's, for example, the do on next, and that doesn't really affect the stream, but it will allow you to process the event that is emitted. So you can, for example, if you have this article coming in and I just want to log it, or I want to put it in the database for caching for some reason, then I could do that in do on next. But generally, yeah, you should try to keep everything within the stream, and yeah, your life will be happier if you do that. Okay, now for some tips. What's really beneficial for me, at least, has been to try to decompose the observables that you're creating. Especially due to the chaining style, if you're not careful, you will end up with a method which is chained like crazy and has a lot of operators. So in the examples I gave, you saw that I created a separate method to return the observable, and later I combined them in some other observable. And that's probably a nice way to do it, because then you can separately test these observables as well. You don't need to apply schedulers there. The testing gets easier, and it's also way easier to maintain. And I've seen some other talks where they just mention that is a good Java practice, and of course it is, but I just want to call it out as well. Another tip is to apply the schedulers where it makes sense. So if you have this API in your app where you're retrieving articles and you're seeing yourself doing this all the time, it might make sense to set up these schedulers in your API, so to say. So you probably want to do something like this, where you already make sure that it's returning on the correct thread, and then somewhere else in your app, you don't have to do the whole subscribe on, observe on dance every time. Makes your code a little bit more readable, and makes it also easier to change these schedulers. Makes it easy to change the schedulers if you change your mind. So if you finally think, well, should it be IO threads, should be something custom, you don't have to go in everywhere. You just apply it on your API. So leading up to the conclusion, I think RxJava is a powerful but different way of doing things. And I think it makes sense for a lot of projects to use it. But when you do, I would recommend to take small steps with it. Don't go full out reactive until you really get what you're solving. And there are many places where callbacks and even async tasks are still okay to use. So don't go in, oh, this is an async task, let's remove it, let's make everything async, RxJava. That would be my main conclusion, and take small steps to learning it. Look at the documentation, try to figure out which combinations of operators work, and those combinations aren't really obvious. I think there are probably multiple ways to do the same thing, but once you are learning this, you will probably be less scared of it, and also a happy use of RxJava. So a little bit early, but with that my presentation has completed. So if there are any questions, I'm happy to take them. Questions? Yeah.
Okay, so from your experience, do you maybe remember some statistics, for example, comparing the same project without RxJava and with RxJava, in terms of, for example, complexity, number of lines of codes, or other metrics?
Do I have statistics on complexity? I don't think I have hard figures, but yeah, it's a little bit of a double-edged sword. I mean, I noticed myself that when you're writing these RxJava things, it's concise and powerful, but yeah, it comes with some cost that is hard to understand for some people. And so I think especially if you're doing like data processing like that, it's probably way more powerful and also better once you have this designed in the way that it should work. It's probably it reduces amount of code. But especially if you're working on a team, you have to work with your team members to understand this all at the same level. It can be you won't be happy in a team where there's this RxJava guy. I mean, that also happens a lot. This is one, oh, he does all the RxJava. Well, that scares the hell out of me, so don't do that. But yeah, I don't have any hard figures, but I see that in our application where we apply this, two things. We started out with this particular application started out with let's do RxJava. So there's a little bit too much RxJava in places where it shouldn't be, probably. And but on the other hand, I see that most of the things that we are now designed properly, it's very easy to compose and take it. Take the stream, transform it. It's usually a simple operation like that. Yeah. Other questions?
Do you have any tips on readability? Do you use comments on that to ease the readability, or are there any other methods?
Yeah, so how to keep this stuff readable, I think my main argument would be to try to compose these observables, like I mentioned. I personally like to keep the subscribers, the callbacks close to the observable itself. That kind of depends on taste, but and also you work with a lot of these inner classes. I like to keep these inner classes close to the observable. You can of course create methods that return you those functions, but it tends to be a little bit harder to reason about when you see this code. You know, oh, what does this function do? You have to jump in somewhere else. So my best tip would be just try to keep the chains short and then compose the various observables. That's probably the best thing, because then you can reason about the separate observables, what they do. So if you're flat mapping to some observable, you might make a new function to create that particular observable, which also allows you to test that separate step better. I think was the question over there still. Oh, we should.
Hello. Yeah, do you hear me?
Yeah.
Hi.
Hi.
My question is a little noobish, but at the beginning when you declare when you explain what was the observables about, you mentioned that once an observable receive an error,
yeah,
you can handle the error, then complete the observable.
Yeah.
And I'm beginning with Rx, and I found myself that what I would like to do is to handle that error, maybe giving some feedback to the user, but keep the observer subscribed.
Yeah, you want to keep it running.
Yeah.
Yes.
So I'm asking which would be the best way to do it on RxJava. Thank you.
So the question, let me summarize it. When you get an error from your observable, you want to keep producing these events. You don't want to stop producing the events. So how would you handle that? There are a couple of options. There's this operator which is called I think on error resume something next. So and you can do that. And one pattern might be that you use the side effect, do on error, and then chain it with on error resume next or retry or whatever. So then you handle the error in your side effect call, but the error will never be reported to the subscriber in that sense. And you can tailor that to only retry on certain errors and let other fall through to your subscriber, for example. So that's one way to do it.
Okay, last question.
I forgot.
Hi. At one of the examples,
Yeah.
I've seen filtering.
Yeah.
It's been used, so I have a question. If I want to, well, take one action at results matching the filter,
Yeah.
and then other set of actions on all the other items, then in this use case, what would be the scenario of using the RxJava here?
Oh yeah.
And
So
is that possible?
yeah, that's definitely possible. I think that's kind of similar. I think to the AutoConnect one. Yeah, to this one. That's probably how I would approach it, because you're basically saying I have this stream and I want to treat it in one way for one thing and in the other way for some other. So you basically want to subscribe twice to it in that case. So you can have this this observable and then filter it for the one case and leave it as is for the other case. And in that sense, you can either combine it or have two subscribers doing the same thing. It depends on how you want to handle that. But yeah, once you filter the stream, it's being filtered, so it's not possible to filter it and then unfilter it at some point. So you basically have to broadcast the same stream to two in two streams basically. Yeah. Right.
Thank you very much.
Thank you.